Hello, let's try to simplify another question from exponential equation. This is our question. We can see our first term inside the root. It is x to the power a divided by x to the power b, and according to our law of indices, we know that since the bases are same, which is x, we can just subtract the power if it's in this form. So we can write this as x to the power a minus b. Similarly, we can do it for this second term and third term inside the root. Also, one more thing I want you to be clear is that if mth root of a to the power n, if any term is in this form, so we can rewrite it as a to the power n times this becomes the power the 1 times m, reciprocal of anything over here. So it becomes a to the power n divided by n. So yes, any terms in this form, mth root a to the power n can be written as a to the power n divided by m. So these are the two things you need to remember while solving the question. So let us go on solving. At first, we can write this form as a to the power x to the power a minus b times a root under x to the power b minus c times b x to the power c minus a. I've just changed the term inside the root here, nothing more. Once again, when you look at this formula right over here on the top right corner, it's in this first, these all terms are in the same form. So let's try to solve it. And this gives x to the power a minus p times this becomes the reciprocal of c, which is 1 by c. So we have to multiply the power of x by the reciprocal of c times x to the power. Similarly, we can do it for this second term, b minus c times 1 by a times x to the power c minus a times 1 divided by b. This can also be written as x to the power a minus b divided by c times x to the power b minus c divided by a times x to the power c minus a divided by b. Now, one more thing you need to remember here is the basis. The same basis having different power. Here x is the basis everywhere and it multiplies, but it has different power. So if the same base having different power multiplies, then we can write the single base and the power simply gets added. So this is our another rule of indices we have to apply over here to get our answer. Here, since our bases are same and they have different power, now let us just add the power. The first power is b minus a divided by c, plus the second power is b minus c divided by a, plus the third power is c minus a divided by b. Now let us just take the LCM for this power. On doing so, we get the LCM as a, b, c. The missing term over here is a and b. Here is just c in the denominator, so we have to multiply by the missing term ab times a minus b. Here, since we've got a, b, and c are missing, so b minus c, plus we've got b already, and so a and c are missing here, so we just multiply its denominator c minus a by ac. Finally, let us do a simple simplification by multiplying this term by distributing AB to both the inner terms, which multiplies it. So let us just distribute this by multiplying. So this gives x to the power, when AB multiplies A, we get A squared B. When AB multiplies B, we get AB squared, and when BC multiplies B, we get B squared C, and when BC multiplies C, we get BC squared. When AC multiplies C, we get AC squared, and when AC multiplies A, we get A squared C divided by the denominator remains as it is. Now let us look for another term having a squared, so it's over here, so we can write as a squared b minus a squared c. Let us look for another term having b squared, so it's positive b squared c minus a b squared, and similarly we can write it this for numerator. Also, let us take a common from these two terms, we get b minus c, and let's take b common from here, we get c minus a, and let's take c common from these two terms, we get c a minus b divided by a b c. Let us once again try to solve it. Here let us find another term having a squared, it's over here, so let us bring these two terms together, we get a squared b minus a squared c. Now also let us write a b squared first, and then let us write a c squared, which is right over here, and finally let us write these two terms b squared c minus bc squared together divided by ABC. Now from these two terms we can take a squared common. On doing so we get a squared b minus c. From these two terms we can take a common and b squared minus c squared, and from these two terms we can take bc common and we get b minus c. On further simplification we get x to the power, I'll write the first term a squared b minus c as it is, and second term I'll just split it into b plus c and b minus c. So now we can write it this way. For this numerator we can write it in this way. After splitting this b squared minus c squared as b plus c and b minus c, other terms remain the same. Now since there is b squared b minus c in each three terms, we can take b minus c common, and the remaining part here for the first term is a squared, for second term is negative a b plus c, and for third term it's bc divided by a b c remains the same. We can further simplify this as this negative a times b means negative ab, but let me first write the power b minus c, and here is a squared, and these two terms multiplies to give negative ab, and this negative a multiplies with c to gives negative ac plus bc divided by abc. Now on further simplification we can write this b minus c as it is, but inside the term, inside this bracket, let us bring this a minus c and make it our second term, minus ab plus bc I've written as it is divided by abc. These all are power, don't get confused. Now we can take a common from these two terms, and we can take b common from this second and third and fourth term. On doing so we get x b minus c remains the same, and here when we take a common we get a minus c, and if we take b common from here we once again get a minus c divided by abc remains the same. Once again I'll write b minus c as it is since there are ac on these both terms, so let us take ac common, and remaining term for first is a, and for second term it's b divided by abc. And finally this is our simplest form, and yes, it's our answer. So when we simplify this question we get our answer this in this form. So I hope you got the, and yes, thanks for watching.